Welcome to the first edition of the FPGA Hack into Mars Hackathon organized by Nokia and Intel. As with many other events, we've been forced to move our event online. During the 22 hours of this competition, you will get a chance to challenge yourself in proposing the most robust way of sending digital data which will achieve the highest bitrate.
First, you need to meet our development board. Its main component is the Cyclone 5 FPGA from Intel. Other important parts for us are the JTAG programmer, a USB to UART converter, and an audio codec. Its input and output are connected with a normal jack-to-jack cable. Your task is to maximize the amount of data that can be sent over it.
We will provide you with a starter project containing IP components for the UART and the audio codec. Your task will be to design a modulator for the transmitting part and a demodulator for the receiving part. You can use any algorithm you want. Sophisticated modulation, coding, and/or compression are all permitted. The only constraints are: only communication between the TX and RX are allowed to go through audio cable, data which is sent back to the UART must be the same as the data received, and the design must fit into the provided FPGA.
But now, back to the hardware. Since we're working online, you won't have it in your hands. All 20 boards are connected to 2 servers, which will run your private virtual machines with all the needed software. When all your simulation checks pass, you'll be able to request a connection to your PC with one of the boards from the Hackathon FPGA cloud for 20 minutes. During that time, you can validate your design or create signal tap for debugging.
Let's briefly introduce our sponsors who have provided a lot of amazing tools for our virtual machines.
Questa is a simulator that will help you to validate and debug your design before running it on the real hardware.
Spin tool can perform link checks and formal verifications of our code.
Parts of your design could also be generated from MATLAB simulink. You can also use it for scientific calculations. The Riviera Pro platform can be used for both debugging and simulation. Also, advanced debugging can be performed there. When you think your project is ready, you should send it for validation, and, up to 20 minutes after, we'll send you an evaluation of your current result. Your final result will be the maximum value you get for any run.
This is a competition, there must be prizes. The winning team will receive Intel Mac Mini PC plus Wi-Fi Smooth Basics. For the second place team, we have prepared Terasic DE10 Nano Kit Development Kit plus Wi-Fi Smooth Basic. And for the team with the third best result, Movedu Sting plus Wi-Fi Smooth Basic is waiting. You can find detailed information about how to access your hardware in the provided tutorials. If you have any questions, our volunteers are waiting to help answer them. Please do not hesitate to ask them.
The first Nokia and Intel Hackathon is open. Happy coding, and may the odds be in your favor.